Assalamualaikum and hi to everyone. Today I will be presenting our group project based on operational research linear programming. So this our team member. First we got Hazel Maria Gordon binti Muhammad Nur Iman Gordon. The second one is Nurliana binti Muhammad Nurji. And then the third is Muhammad Daniel bin Mokhtar, that's me. And the fourth is Nur Syafiqah Najihah binti Suzaha. And the last one, Pravin Raj anak lelaki Nando kalian. So does you guys know what linear programming is? So basically, linear programming is a fundamental mathematical optimization technique that helps us solve complex real-world problems by finding the best possible outcome within given constraints. So let's move to the next slide.
Hello, my name is Pravin Raj, I'm Lalaki Nerinjali, and I'll be explaining about the introduction. A linear programming model is a mathematical representation used to solve optimization problem where the objective is to maximize or minimize a linear function subject to a set of linear constraints. It provides a systematic way to determine the most efficient allocation of limited resources such as time, labor, or materials to achieve a desired outcome. The model includes decision variables, an objective function and constraints, all expressed in linear form. Linear programming is widely applied in business, economics, engineering, and operation research to support effective decision making.
Good day everyone, my name is Nurliana binti Muhammad Nurji. Today I will present a linear programming case study involving Healthy Bites, a company that produces two types of snack, which is energy bars and protein cookies. Each product uses two limited ingredients, which is oats and nuts. The company goals is to determine how many units of each snack to produce in order to maximize total profit while staying within the given resource limit. So let X be the number of energy bars produced, Y be the number of protein cookies produced. So the objective maximize is Z equal to 2.5x plus 3y. So subject to the constraint is 100x plus 150y less than 15,000 for oats, 15x plus 100y less than 10,000 for nuts, and of course x equal to x more than 0, y more than 0. So step 1, finding intercept. So to apply the graphical method, we first convert the inequalities to equalities and find their intercept. So for oats constraint, 100x plus 150y equal to 15,000. So if y equal to 0, then x will be 150. So point will be 150, 0. So if x is equal to 0, then y equal to 100. So the point will be 0, 100. For nut constraint, so 50 plus 100y equal to 10,000. So if y equal to 0, then then x equal to 200. So the point will be 200, 0. So if x equal to 0, then y equal to 100. So the point will be 0, 100. So these are the points where the lines intersect the axis. 2. Plotting and feasible region. So next we plot the two constraint line on a graph and shade the feasible region, which represent all combination of x and y that satisfy the resource limit. From the graph we can see the shaded gray region, which is bounded by the two lines and the axis. So this feasible region include all the possible production combination that are within the company resource limit. So step 3, identify corner points. To solve the LP problem graphically, we now identify the corner points of the feasible region. So point A is 0, 0. Point B is 0, 100. So the y-intercept of both lines. So point C is 150, 0, which is x-intercept of the oats constraint. Point D, the intersection point of the two lines. So next we will pass to next presenter, which is Muhammad Daniel, to calculate the intersection point.
So for the step 4, first we need to find the intersection point of the two lines. So the first equation is 100x plus 150y equals to 15,000. The second equation is 50x plus 100y equal to 10,000. As we make the equation 3 from the equation 2 multiplied by 2, so we get 100x plus 200y equal to 20,000. So 100x plus 150y equal to 15,000. So after settle calculation, we get 50y equals to 5,000. So we want to get y. So y equal to 5,000 divided by 50. So y equal to 100. So we will replace y with 100. So we get 100x plus 150 multiplied by 100 equals to 15,000. So 100x plus 15,000 equal to 15,000. 100x equal to 15,000 minus 15,000. So x equal to 0 divided by 100. So lastly, x equal to 0. So this gives us our intersection point at 0, 100. So for the step 5, now we can evaluate our objective functions. So z equal to 2.5x plus 3y at each corner point. So at point 0, 0, we get z equal to 2.5 multiplied by 0 plus 3 multiplied by 0 equal to 0. At point 150, 0, so we get z equal to 2.5 multiplied by 150 plus 3 multiplied by 0 equal to 375. At point 0, 100, we get z equal to 2.5 multiplied by 0 plus 3 multiplied by 100 and equal, we get 300. So the maximum value occurs at point 150, 0, giving us a maximum profit of $375. So the conclusion is, the company can produce 150 energy bars and 0 protein cookies. So we proceed to the next slide.
Okay, so I'll present the second question. A company has two groups of inspectors, namely Group A and Group B, who are assigned to do a quality inspection work. It is required that at least 1,800 pieces are inspected for 8 hours per day. It is known that inspectors of Group A can check pieces at a rate of 25 per hour with an accuracy of 98%, while inspectors of Group B can check at a rate of 15 pieces per hour with an accuracy of 95%. The inspectors of Group A and B are paid Rs40 and Rs30 per hour respectively to do the work. Each time an error is caused by any inspector, it causes a loss of Rs20 to the company. The company has 8 inspectors in a Group A and 10 in a Group B. The company wants to determine the optimal assignment of inspectors to minimize total inspection cost. Formulate in LPT.
Minimize inspection cost, we are step by step finding the minimum cost. The objective is minimize total cost z equal to 400x plus 450y, which our first is 4x plus 3y more than 120. Next is x less than 8, which are max hour for Group A, y less than 10, which are maximum hour for Group B. Next is x, y more than 0 is non-negative value. So y is correct constraints, which are plot the line, which are 4x plus 3y equal to 120, x is 8, y is 10, which shade the region satisfy all inequalities. Step 2 is, first is x equal to 8, find y for 8 plus 3y 120, which are y is 6.67, point A is 6.67. Next is x equal to 8, y equal to 10, point B is 8, 10.
Okay, my name is Nurshafika Najiha. So I'll present the step 3, which is evaluate ZAC at each point. So at point A, which is ZAC is 6,201 and 50. At point B, ZAC is 7,700. So for the step 4, which is choose the minimum, because of A is the minimum cost, which is 6,201 and 50. So A will be the minimum cost because Group A worked 8 hours and Group B works 6.67 hours. That's all. Thank you.
Last but not least, linear programming is a powerful tool for solving real-world optimization problems. By modeling objectives and constraints mathematically, it enables decision makers to allocate resources efficiently and make informed and also strategic choices across variable industries. Thank you.